Okay, so for question 5, let's go to our calculator, okay? So let me get myself situated here. All right, so calculator we go. Again, we're gonna input some new data. So I need to do is hit stat edit and go up to L1 and clear it, or you can just shut off your calculator and turn it back on. That will clear out your data too. For my L1, those are my X's, 0 through 6 it looks like. And then for your L2, those are your Y's. So go ahead and make sure you get everything put in there correctly. Then always do a quick check, did you type it in right? Because you don't want to do all this wrong, all this right, but with incorrect data. Okay, first question is, describe the association in the data. So positive correlation, negative correlation, or no correlation. Second, y equals, make sure plot 1 is on. If it's not, we hit second, y equals, so plot 1, hit enter again, the off should become on, and then we hit graph. Now your window looks like this. To make the window appear, or you make your data points appear, hit zoom, option 9, zoom stat. Reconfigures your window, and we can see we have a positive correlation happening, a positive association happening. So far, so good. Now, part B then is we need to go find the correlation coefficient. They already gave us the equation, so we got to turn on our correlation coefficient to answer that. Second, 0 for the catalog. Go back down to the D's to find the diagnostic on. If you did not turn off your calculator, it will save it for you. But I'm just going to go, as this is a new problem each time, just in case. Hit enter twice, once, twice. Stat, calculate, option 4. Go down, run it. We just want the R value. I can see right here, A and B, they already gave me this, so that looks good. So we just got to make sure we can put in A properly to nearest thousandth. So 0.956. Let me go back to my screen. We said this was a positive, negative, or sorry, I don't want to say negative, 0.956. Now, to get these, we load our table. They got our observed X and Y, that's our L1 and L2. Now to do the predictions, we use our equation. And to do that, we're going to do, again, plug in the observed X, which in this case was 0, and then do 28.57. When you do that, that's when I get that answer. And that's what they did on the next one, but on the next one, they plugged in X as 1, because, well, we're at X is 1, plus 28.57. So when you plug it into your calculator, that's how you're getting 85.71. For this next one, I'm going to plug in X as 2. So now I have to go to my calculator and plug that in. 57.14 times 2 plus 28.57. And you should be getting 142.85. I go down to the next one. Plug in X as 4. So I go type that on in, get my predicted Y, 257.13, and they did the last two for me. Now to get the residuals, it says do the observed Y minus the predicted. So they did the observed Y is 50, that's coming from right there, minus the predicted, which was 28.57, which is coming from right there that we calculated. So in this case, the observed Y was 75 minus 85.71. So 75 minus 85.71 gives me negative 10.71. And that's what they did here. 175 minus 142.85. And when you do that, you can confirm that they gave you the right number there, 32.15. So then we need to do this one as 250 minus 257.13. 250 minus 257.13, negative 7.13, and then 375 minus 371.41. 375 minus 371.41 is 3.59. Now, as been true on the quizzes and will be true on the tests, we take these residual values right here and we put them into our table with the observed x versus the residual values. Now, I will always give you this graph. You now need to interpret this residual plot. Can you see a pattern here? I do not see a pattern. So no pattern implies that it is linear. Patterns imply not linear. So, does the data appear to be linear? Yes. The residual plot indicates a linear model may be a good fit for the data because there is no pattern, and that will be a drop-down menu like we've seen, okay? All right.